I'm going to go over what appears to be most of your homework here on this video from page 176. The first question that was requested, number 28, was asked about finding rational zeros. It doesn't specifically say how to get the possible rational zeros, so I decided to put it into my calculator and graph. Without actually finding the zeros, it appears there's one at -1 and 5. So -1 and 5 appear to be correct. There potentially could be 4 rational zeros, but the other 2 might be imaginary. It's hard to say. So I'm going to just verify that -1 and 5 are zeros. I'm going to look at my table. If I see -1, yes, that is 0, and 5, that is 0 as well. So, well, let me see, are there any others we should be using? Oh, 1. Well, that's unfortunate. So I'm going to go ahead and use synthetic division with these numbers. We don't need a placeholder. -25, there we go. Okay, now I'm going to go through and divide by 5. Way to start strong. 2 times 5 is 10. There we go. And there's our remainder of 0. And lastly, we are going to divide by 1. That leaves us with the polynomial 2x minus 5 as my last 0, so set it equal to 0, x equals 5 over 2. So my rational zeros are -1, 5, 1, and 5 halves. In number 36, list all the possible rational zeros is where it begins. So they're asking for P over Q. Remember, P are the factors of 15, Q are the factors of 4. What goes into 15? Plus or minus 1, 3, 5, and 15. Over the factors of 4, that's plus or minus 1, 2, and 4. You need to write these all out separately though. So first we're going to put everything over 1. That's plus or minus 1, 3. These are all plus or minus. I'm just not saying plus or minus each time. Okay, so there's everything over 1. Everything over 2. 1 over 2 is a half. 3 over 2. 5 over 2. And 15 over 2. Oh, goodness. Now everything over 4. I am rapidly running out of space, so I'm going to come down here. Plus or minus 1 over 4. Plus or minus 3 over 4. A lot of times they reduce and you don't have to write them all down, but we're not getting lucky on this one. 5 over 4 and 15 over 4, which looks like a ton of possible rational zeros, but if you think you start with infinitely many, then that's paring it down quite a bit. Sketch the graph of f, so sum of the possible rational zero. Sketch the graph of f so that some of the possible zeros in part A can be disregarded. Okay, so they're telling you to go to your y equals. Okay, so when I look at this, I can pretty much see that I don't have anything going beyond -2 and 3. -2 and 3. So that's going to allow you to like disregard anything that's negative. All these, like, they just go away. What did I say? -2. So these would be eliminated based just on that sketch. Then it goes on, part C, determine all of the real zeros. So once you have this much, then you would directly substitute some of these into this equation and see what gives you 0. It appears here at my graph like -1 is going to work. So f of -1. And we're going to see if we plug that into here, what would we get? Well, I have it here, so I'm going to tell you it gives us 0. Sweet! So use -1 with your synthetic division. Okay, leaving us with 4x squared minus 16x plus 15 equals 0. And we can try to factor that. That's going to give me 6. That's going to give me 10 if I make them both negative. Sweet. We are good to go as factors. I'm just checking myself and multiplying back. Setting each of these equal to 0, gives us x equals 5 over 2, x equals 3 over 2. So your zeros, which word I just wrote, are 5 halves, 3 halves, -1, and we're good to go. And you can see these are actually up here as options. The next question was number 40. And we're listing all of the possible rational zeros. So we're doing P over Q, possible rational zeros, plus or minus 1, 2, 3, 6, oh goodness, 9, and 18. I thought this was a good idea. Over all of the factors of 4. You would need to separate all of these. So putting them all over 1. All of them over 2. Okay, so I did 1 over 2. Now 2 over 2, we already have that. That's 1. 3 over 2. 6 over 2 is 3. 9 over 2. And 18 over 2 is 9. We have that one. Now everything over 4. 1/4. 2 over 4 is a half. We have that. 3 over 4 is an option. 6 over 4 is 3 over 2. 9 over 4. And then 18 over 4 is 9 over 2, which we have. Okay, so there's all your possible rational zeros. You are to determine where the real zeros are based off of those guesses. Okay, so, oh, and what can we eliminate? Well, you don't have anything that appears to be smaller than -2 or greater than -2. So right away, that's going to get rid of these. Okay, so it pares it down quite a bit. You can't really see that, can you? Okay. It appears to me like -2 is 1, so I'm going to peek and not really substitute it in because you're waiting long enough. If I do f of -2, it does give me 0, so I'm going to use that in my synthetic division. Gives me 4x squared minus x minus 9, set it equal to 0. Ooh, see if it's factorable. Let me try. We do 2 and 3, 2 and 3. That's going to give me 6, and that's not going to be good. 4 and 1, 3 and 3. That's no good. All right, I'm going to pause so I can think it through. Okay, I confess I could not find it. Factorable situation here. So I am going to use the quadratic formula, a being 4, b being -1, c being -9, x equals a negative b's 1 plus or minus the square root of 1 squared is 1 minus 4 times a times c is 4 times -9 all over 2 times a is 8. X equals 1 plus or minus the square root of 145 all over 8. I don't think that simplifies. And I have not looked at these answers, so, well, I did look at them because I took a picture of them for you, but I don't have that book in front of me. So, I don't think that square root of 145 simplifies, so your zeros here, which makes me very curious, are -2 and 1 plus or minus the square root of 145 all over 8. 145 divided by 5, 29. Yeah, that doesn't simplify. So there are your 3 roots. You have the -2, and then you have the plus version of this and the minus version of that for your zeros. Yeah, that was a treat. Okay, number 48 asks for you to find the polynomial function with the real coefficients that has the given zeros. Now, it gives you 5, 3, and -2i. That means that positive 2i is also a linear factor, so, or a 0. So write your linear factors, x minus each of these. Okay. I'm going to go ahead and multiply the binomials together using FOIL. And these two binomials are a conjugate pair, so my inners and outers are actually going to cancel, leaving me with x squared minus 4i squared. And I know we can tweak that, can't we? X squared plus 4 is your polynomial. Now, we need to distribute throughout here. So I'm going to multiply each of these two terms by an x squared, giving me x to the 4th plus 4x squared. Distribute the negative 8x gives me negative 8x cubed minus 32x. Distribute the 15 plus 15x squared plus 60. Okay, so combine your like terms. X to the 4th. I'm going to put this back in order now. Minus 8x cubed. X squared would be 19 of those. My x's, negative 32x plus 60. The next problem that was requested was number 82. It says find all of the zeros of the function. When there is an extended list of possible rational zeros, use the graphing utility to graph the function in order to discard any rational zeros that are obviously not zeros of the function. So if you're looking here, your possible rational zeros, plus or minus 1 and 5 over plus or minus 1 and 2. Goodness gracious. Okay, separate those. Plus or minus 1, plus or minus 5, plus or minus a half, plus or minus 5 halves. Okay, so it's clearly not going through these or the negatives of these. So I am going to, you know what I'm going to do? I'm going to change my table setup here to count by halves, and that'll tell me if positive a half is 1. And it is. Okay, so I'm going to use positive a half in my synthetic division. No placeholders necessary. Each of these are divisible by 2, so I'm going to go ahead and divide that out, giving me x squared minus 2x minus plus 5, excuse me, equals 0. Factors of 5 that add to negative 2, well, not going to happen. Plus, we had already sketched the graph. We knew there was only one rational 0 here, so the other two have to be imaginary. Discount any rational 0. I think, oh, it must want you to list all of the rational, or all zeros. Okay, so we know one of the zeros is a half. I need to see what zero is coming about from here. We know it's not factorable because we only had one real 0. So I'm going to use completing the square. Since my leading coefficient is 1 and my middle term is negative, my middle term is even, excuse me, the middle term is even, so it makes it easy. So divide it by 2, negative 1 squared is 1, add it to both sides. This now factors to x minus 1, the quantity squared equals negative 4. Square root both sides, plus or minus 2i. Square rooting negative 4 is 2i, and then adding 1. 1 plus or minus 2i is a 0 and a half. There's one more that was requested. And it's from the same problem set, so we're going to do our P over Q here. Plus or minus 1 and 5 over plus or minus 1, 3, and 9. Make our list, putting everything over 1 to begin with, everything over 3, and over 9. And for crossing it out purposes, it's probably better to write them all separately, but oh goodness gracious, that's a lot. So 9x cubed minus 15, oh goodness, what did I do? 15x squared plus 11x minus 5. Oh, is that right? Goodness, that looks very similar to the last one. Okay, good figure. Okay, I'm going to graph it and see what it looks like I can discard. It looks like it's going through about 1, so I know that a lot of these are going to go away. I'm going to check and see if my 1 is 1. It is. So f of 1 is 0, so I can use 1 in my synthetic division. Since it only has one x-intercept, the other zeros must be imaginary. This looks pretty horrible for using the quadratic formula because of that leading coefficient. So I'm going to go ahead and use the, did I say it was horrible for quadratic formula? It's horrible for completing the square, so I'm going to use quadratic formula. X equals negative b is a positive 6 plus or minus the square root of 36 minus 4 times 9 times 5 all over 2 times 9 is 18. I'm finding the discriminant now. I know it's going to be negative, right? Negative 144. So x equals 6 plus or minus the square root of negative 144 is 12i over 18. Everything there is divisible by 6, so 1 plus or minus 2i all over 3 is one of your zeros, 1 is the other 0. This is actually 2 plus and minus, and there's your third. These are all your zeros. All right. I hope you guys have a great day. Let me know if you have any more questions. Take care. Bye.